for Tuesday, February 28th. We're going to start the group quiz.
Lesson 16.
Lesson 16. And it's the group meeting quiz, not the homework quiz. Okay, in a pie chart, why are the slices sectors different sizes?
Each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category.
Yes.
Or we can go with that the charts are more visually appealing when the slices are different sizes. That makes a lot of sense. It's kind of boring when they're all like the same size. You gotta like break up the monotony.
That's what they teach us in user interface class. That's
yeah. How are bar charts and Pareto charts related? I have the instructions here. Bar chart.
I want to say it's the third one, that they're ordered largest to smallest, going from left to right.
Yeah. That's the only difference, right?
Or they're constructively tossing a coin several times.
I like that too.
No. I think, yeah, you are correct. The only difference is the order. Okay. We conclude that p hat is normally distributed if NP is greater than or equal to 10.
Marie, I love your terms. I just have to throw that out there.
P hat, that's what they call it in the video.
Is it really?
Oh, do they?
I
didn't know that. I thought you just came up with P hat, and I was like, X bar, P hat.
That's what it's called.
You thought she was being funny?
Yeah.
I did.
Okay, I'll take the credit. I like that.
Okay.
Okay, is greater or equal to 10, and n times 1 minus p is greater than or equal to 10. Is p the true proportion or the sample proportion? Maybe it's the sample.
I want to say the sample proportion, but
I'm pretty sure.
I'm also looking for something to back that up.
I am too.
That's okay. We've got 2 answers and like 6 attempts. So
I like that.
Okay, it's the sample proportion. Okay, what is n?
The sample
clearly
size.
the number of candidates. Some of these answers are great.
I think that this quiz is like intentionally trying to give us some of the answers.
The sample size?
Yeah, I'm gonna go with the sample size.
If p equals 1/4, what is the smallest n that satisfies the requirement?
$40?
No, wait.
I'm gonna say 40.
How did you get 40? 10?
The lowest requirement would be, well, because it's 1/4, right? And in order to get n to equal 10, we'd have to multiply 1/4 by 40. Because see on the top, it's n times p is greater than or equal to 10. So in order for that to be true,
Oh yeah.
Okay.
n would have to be greater than or equal to 10. If we multiply each side by 4 to get rid of the 1/4, and 10 times 4 is 40. I don't know. And then the other one, n times 1 minus p, would be n times 3/4, which would be easier to satisfy. So the other one is the one that's relevant. If that makes sense. I don't know. We have more than one attempt, but that's what I think the answer is.
Okay.
Yeah, we'll go with it.
40.
Okay. So use the following information to answer the next 2 questions. Suppose n equals 24 and p equals 0.4. What is the mean of the party hat?
Party hat. There we go.
Party hat. Love it.
That's what I'm going with.
Yes. Okay. So,
Mean of party hat equals P. That is a formula from the book.
Yep.
So
that should be
0.4.
0.4.
Standard deviation. Oh boy, that looks like a fun formula. The square root of P times 1 minus P divided by N.
yeah. So how do we do this one? Me?
We have N and P, so we just have to fill out the formula, and then that'll be the standard deviation.
And it's, let's see, P minus 1 minus P? Or was it? Oh, P times 1 minus P.
So what? So we get the okay.
Minus divided by, what was our N? It was 24.
I got 0.004.
So did you do P hat minus 0.4 divided by the square root of 0.4 times 1 minus 0.4 divided by 24?
I think so, yes. The order of operations is kind of hard to visualize orally.
Yes. Let's put in its but we don't have the z-score. Are we using the correct formula?
Okay. And what did you get for 9 again, Mitch?
I'm recalculating. I think I messed up.
So the mean of p hat equals p.
Yes, yeah. Oh, for number 9, sorry. Oh wait, no,
Yeah.
we're looking at standard deviation. I got 0.004, but I think I made a decimal mistake.
Okay.
What did you get?
I'm recalculating it just to be sure because my number was
Okay.
funky. And Google wasn't wanting to play nice with the calculator. Is that right? I got 0.1.
Yeah, that's what I've got.
Yeah,
Okay.
I got two.
Wait, what? Okay, hold on. 1 minus. Why is this in there?
That seems right? 0.1. I think I was confused because I pressed the square root button and it like did it, and then I pressed equals, so it squared it again. Or it,
Oh, gotcha. Yeah.
I don't know what happened, to be honest, because that's not even close to what I got before.
We'll blame
Anyway,
technology. Your technology freaked out. We'll leave it at that.
so number 10, what is party hat? Rounded to 2 decimal places. The mean of the party hat is P, so we know what the mean is. But do we know what P hat is?
Okay. Party hat equals X over N.
Yes. So the mean would be
Which
0.
section in the book is that in?
I'm just seeing it down in the summary.
Ah,
That's where I usually go to grab the formulas.
summaries are really good.
Yeah, and there is on page 14, the worked example. It says party hat equals X over N.
Okay. So
So this would be 0.3 divided by 100.
is PX though? Or
Is
is
that
X,
the mean?
or is X the what her actual batting average is? 0.3.
Maybe
Hold on.
isn't that the same though? Or
I do not know.
well, Brittany's batting average is 0.300, which is the same as P 0.3. We want to determine the probability she will get more than 35 hits in her next 100.
But I'm not sure which one
So wouldn't it
X
be?
is supposed to be.
I think
But
X.
isn't it 35 divided by 100? So if you guys look on page 14 of the book, it says if a coin is tossed n equals 25 times, the heads is observed 17 times. The sample proportion of heads is party hat equals X over N, which equals 17 divided by 25.
Yeah. And
So-
then in section 2.1.1, political polls, it's talking about a survey, and it says that in one survey, N equals 1,024 people were polled, and X equals 565 of the respondents who said that they would vote for the Republican candidate. So X is supposed to be the proportion that represents like the variable.
Okay.
So I would
So would it be
think,
35?
yeah, I think Marie's right, and it's 35.
So it would be 0.35.
Yeah.
Okay. And then the standard deviation, we just have to do that formula again.
The standard, yes. I like the ones with the formulas.
I got 0.046.
Yeah, that's what I'm looking at too. What is the z-score? That's a great question.
P hat, party hat minus P over the standard deviation.
Yeah.
Okay, did you 0.046? Okay. Okay, the Z. Did you guys get the Z score?
So to get the z-score, we got to do
Party hat 0.3
0.35 minus 0.3
divided
divided by
by
0.046.
So 0.5 divided by 0.046.
Yes, I got 1.087.
by 0.0. So you got, what was your answer again, Mitch?
1.087.
Okay, I got 1.091.
Did you do P minus P hat or P hat minus P?
Did because it should be 0.35, which is P minus P hat. right?
No,
Well,
P was
0.25 is the p hat.
Yeah.
Minus 0.3 would get you 0.05 divided by 0.046.
Which gives you 1.08695. So 1.087.
Yeah.
Okay.
What is the probability Brittany gets at least 35 hits in her next 100 at-bats? So what we want to do is plug in the z-score, right? To the normal probability thing.
I think so.
I think so. And it was more than? Yeah. Well, I guess that would be at least. So wouldn't it be the middle section and the right section?
That is a
Says we enter the z-score into the normal probability applet and shade the area to the right of this value.
Oh, yeah. So just the right side.
13.85%. Oh, so 0.138139.
Yep, 0.139. I feel like compared to the last couple of weeks, this is cake.
Yeah, I agree. I'm actually going to do the homework quiz right after this just so that it's like out of my mind and it's done.
Oh, we can do it when we're done with this. I'll just stop the broadcast.
Yeah, I was planning on doing it anyways.
I usually wait until Saturday night. Actually, they're due on Saturday night, but they're not on. They don't lose their availability until Monday morning. I usually do it either Monday morning or.
I do too. Okay, Midge, I've done the same thing a couple of times.
I'm
Because
just glad I'm not the only one.
okay, I've done some on Sunday.
Coming clean, guys. Feels good.
I like this open, honest atmosphere we have going on. That's okay.
I'm normal, yes.
So if the true proportion of people who support a political candidate is P equals 0.52, equals 2,000 people are surveyed. We want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What is the standard deviation of party hat?
All right. You guys memorized the formula yet?
Almost.
50% standard deviation. I should have this memorized.
I got 0.011.
I'm just waiting to find out we used the formula wrong.
Yep. Oh, this is so easy. And then we submit it and we get like a 0.
Uh-oh.
If we get a 0, I'm dropping out of school.
What? You can't.
That's a little extreme.
For that.
No pressure, guys.
Just go get like a nano degree or something. Go take some Udacity classes.
This is the last straw.
Nano. What's that?
Basically they offer it for a few different things, but it's mostly like programming.
Okay.
And they just compact everything into a smaller amount of time and more focused on, like, say you wanted to be an Android developer, there's a nano degree for Android development, which you just focus on doing Android.
Okay.
Whereas like the 4-year degree that we get from BYUI, we don't really focus on anything. We just learn a whole lot of general stuff.
Where do you get a nano degree from?
A bunch of different websites offer them. The one that I favor, honestly, and my boss keeps pushing on people, is from udacity.com.
Okay.
And the only reason that that one's such a great one is because they go and get like quality teachers. Like the people that are teaching the Android nanodegree stuff work for Google.
Okay.
And if anyone knows Android, it's Google.
Okay.
So
Cool. That's my backup plan. Thanks.
yeah, that's my backup plan.
I'm about to graduate, but me too.
Yeah, this is my last class, and if I don't pass, I'm just dropping out and doing a nano degree.
No pressure.
Oh, I have a lot
Really?
longer than that. Okay, so you guys got for 14, did you get 0.000?
For 14, I got 0.011.
I must have did this wrong.
Yeah, that's what I got too. I'm gonna rerun the numbers just to double check.
Yep, nope, I didn't do the square root, so
Oh, okay.
we're good. Okay, 15. What z-score would you use?
How do we find that it says the x over n again? Is x, yeah, what's x? Is it 1,001?
Is it 0.5? Is it 50?
I would think X in this case would be like 1,001 because it's getting less than 50% of the votes. Or no, it would be like 999. So the other way around. Because that's the target for.
What about the p though? The p equals 0.52. I guess that's just for this finding the deviation and stuff. I don't know.
I think so.
And our z-score, because our value, because what we need is p hat. Which I thought Ben, isn't it the 1 in 1,000 or 50%?
I think so.
Should we try it?
Yeah, sure. Why not?
So wait, what are we going with? 999?
Yeah,
Is it not?
I think so. Because it would have to be getting less than 50%. So that would put it 50. And the closest we
what's
could
our-
get is 999.
What if we did 1,040 since like 52% is supporting him and 52% of 2,000 is 1,040? I don't know. I
Sure.
feel like there are so many numbers that you could use.
Yeah. I'm looking through the reading right now to see if there's anything that. Oh, hey. What do you know? Section 3.3.2, example political elections.
Okay.
Thank goodness.
So if the true proportion of people who support a particular political candidate is P equals 0.48, and if N equals 1,041 people are surveyed, what's the probability that the results of the survey will suggest that the candidate will win the election?
Yeah.
So we're just doing this question the other way.
Yeah, so the p hat is just 0.5. It's 50. So you look at the example, so it would be 0.5 minus 0.52. Right?
That makes sense to me. 0.5
Yeah.
for an election. I don't know.
Mm-hmm.
And
Because
then-
that's what they used here, and it was more than.
I guess X is like the possible outcomes. So if there's 2 outcomes, it's 1/2. If there's 4 outcomes, it'd be 0.25. I don't know. Or that's what
Yeah, so it's saying the
Yeah.
score is party hat minus P over the standard deviation.
yes.
Yeah.
So yeah, we would just go with what was P? I have too many screens going on. Let's this over here.
It's 0.52. That was P.
Yep.
So we're going to get a negative number.
So I got a negative 1.79 as my z-score.
A negative 1.818.
Yeah, I can't square mine because it's a negative number, or unsquare it. It just says invalid.
Okay, but hold on, our standard deviation was
0.011.
0.011.
Yeah.
So
So
you
it
got
would be
negative
0.02.
divided by 0.011.
Mhm.
Okay.
But it's negative.
Yeah, so it is negative 1.818. Sam's right.
That's what I got, but it also said
Yep,
that there was an
negative.
error.
Your
But
technology is
are we shading to the left?
I think so
Yeah.
because we want to see what the probability is that they'll lose, which is 0.035 for me.
Yep.
All right, let's get a 0.
What was
Hold
16?
on. What was
16, we got
16.
0.035.
Oh, I totally messed that up. Give me just a second. Oh.
Hey, did you submit?
I haven't. Do you want me to? I can go first.
Okay, Mitch.
Nah,
I already did.
it's whatever. Well, fine, Mitch.
We got everything wrong.
Seriously?
No. Well, we got one
Dumbass.
wrong, and it's number 5. I don't think we're ever going to find the correct answer.
Ooh, that's a toughie.
Number 5?
Yeah.
I'm going to go with pickles.
Is it the true proportion?
Well, yes, it's the only other option.
Oh
Well,
my
I put sample proportion, so yeah, it's a true proportion.
Oh. Well. Okay.
Cool.
What are the odds that the only question that we had a 50-50 chance at is the only one we got wrong?
That was my bad. I should have read through this better.
Well, we all looked for it.
We all thought it was. Yeah. All right, 100%.
100. Okay, I'm going to stop the broadcast 1 second.
Okay. Now we can talk bad about the team.